In example 18 here, we're just going to apply the definitions of the scalar or dot product. Question A is asking us to get the dot product between A and B. So if you remember, A dot B will equal the first component in A times the first component in B, and so on. I'll just write those out. So in other words, that's equal to, so we've got 1 times I for A minus 2 times I for B, so that's minus 2 plus. We've got minus 2 times plus 3, so that ends up being minus 6. And we've got 3 plus 4 is 12, sorry, 3 times 4, so that equals minus 8 plus 4 equals 4. So the dot product between A and B is 4. In other words, we just have a number here, okay? So now in the next one, it's a little bit of a diversion from that. We're looking at A dot A. So in other words, A1 times A1 plus A2 times A2 plus A3 times A3. And we've got 1 times 1, and minus 2 times minus 2 is positive 4, and 3 times 3 is 9, so that equals 14. So I just also should mention that it should be pretty obvious to you right now that if I have a look at this, another way of looking at this is A1 squared plus A2 squared plus A3 squared, which is actually equal to the square root of A1 squared plus A2 squared plus A3 squared, all squared. And if you recognize inside the bracket, that is just the magnitude of A squared. Okay, so there's a little hint for you there. You can just see it by doing it, that A dot A is actually equal to the magnitude of that vector squared.